So, hello everyone, and welcome to University of Toronto Institute of Transportation Engineers webinar series. This webinar is co-sponsored by Smart Freight Center. I am pleased to introduce our speaker, Dr. José Holguín-Veras. Dr. Holguín-Veras is the William H. Hart Professor and Director of the VREF Center of Excellence for Sustainable Urban Freight Systems at Rensselaer Polytechnic Institute. He is the recipient of numerous awards, including the 2013 White House Transportation Champion of Change Award and the 1996 Milton Pekarsky Memorial Award. His research group works on freight transportation modeling and planning and disaster response logistics. In these areas, he and his group are among the most published and cited scholars in the world. His research has led to major changes in transportation policy to improve urban freight systems. His work on disaster response has played an influential role in disaster response procedures and has led to deeper insight into how best to respond to disasters and catastrophic events. Professor Holguín-Veras is in numerous leadership positions at professional organizations, public sector agencies, and leading journals. Please welcome Dr. Holguín-Veras.
Fantastic. Okay, let me go ahead and share my presentation.
Sure.
To have the opportunity to speak to this audience because I believe that the University of Toronto is one of the best universities in the world, and also the Freight Transportation Group at the University of Toronto is one of the leading research centers, and I'm very pleased to have the opportunity. Tell you the stages I went through when I received this kind of invitation. First, I was surprised. I could not believe I had been invited to this. Second, I felt quite happy with myself. And then next, I went into a state of panic. What I'm going to tell these people? And finally, at the end, desperation. I said, this presentation is impossible to make. Too many slides, too much material. And basically, let me show you then what I ended up doing. Essentially, what I'm going to do here, I'm going to kind of share with you what I consider to be a key principle of dealing with complex problems, and then I'm going to go to the key component of the presentation. And at the end, I'm going to talk about what I consider to be the most promising avenues to address climate change by means of freight transportation policy and planning. Essentially, a key principle if there is one idea that I want to leave with you is this one, that complex problems do not have trivial, magical, or straightforward solutions. Essentially, if they were magical solutions, somebody would have found it before us. You see? Now, like a magical solution to these problems, question yourself, because history suggests that you're likely to be wrong. Now, I'm going to talk about another important concept, that is the efficiency paradox. And in the case of freights, this paradox manifests in the following manner. Essentially, the reality is that trucks, both light, medium, and heavy, consume tremendous amount of energy. Now, but it happens that since the 1970s, there has been a consistent increase in energy efficiency that basically amount to 1.4, as indicated in this slide, between 1.4 to 0.3%. But at the same time, the total amount of energy consumed by the freight sector have increased. And then I suppose that all of you are wondering, but how could that be? we have more efficient engines than before, and they were consuming more. Well, the answer to that, believe it or not, was produced more than 100 years ago by this fellow. It's a British economist called William Stanley Gibbons, that at the height of the Industrial Revolution, he basically was to examine develop, we're going to reduce the consumption of coals. Back then, the UK was using the local coal mines to power the Industrial Revolution. And there was concerns about these coal mines being depleted. And the idea was that new machines basically will reduce consumption. What Stanley Gibbons found was that it was all the opposite. Basically, the new machines basically induce demand. And inducing demand, they ended up basically exhausting the coal mines even faster than before. In essence, this is a classic problem of the demand induction. Now, nowadays, we are experiencing a similar effect because we have new technology, new freight technologies, but also at the same time, this technology has been changing demand. Why the energy increase has increased? Globalization, e-commerce, etc., etc., etc. Key insight: technology is part of the solution, but it's not the solution. Now, the issue here at the core of the efficiency paradox is the fact that demand and supply co-evolve. Demand changes, and then the supply technologies basically change as well in response to demand, and vice versa. In essence, the induction of supply, of demand, basically in most cases, it ends up eating away the benefits, the original benefit produced by the substitutions of old technologies for new technologies. Essentially, demand management is key. In all of that, metropolitan areas play a tremendous role because, in essence, metropolitan areas are both major centers of economic activity and also major centers of pollution. Now, in context, the goal and objective of freight policy and planning should be to maximize the benefits associated with the activity. Production, in most cases, the production and consumption of supplies is an economically beneficial activity. What is, in most cases, problematic is this activity. Essentially, we need to fighting climate change is what we call a collective action problem, in which multiple partners have to collaborate towards the solution. In this particular context, let me give you a sense about our research areas. Primarily, we work on these four topics: sustainable freight system, behavior, demand modeling, and also disaster response logistics. And basically, we're funded by a number of funding agencies, and we do all the way from implementation all the way to theory and analytical models. Essentially, if I were to characterize what we do, we rest on three pillars: empirical research to understand reality, behavior research to between the participants in supply chain and freight transportation system, and also we develop novel analytical. About the type of things that we do, what we have here, I'm not going to dwell much on this, but this is basically one of the theoretical developments that we are very proud about, because in essence, what this nasty looking thing here is, this is basically a form of the gravity model. And thing is that this model that we develop it was designed for free activity. That model considers tools. It's the only analytical model that is able to consider tools with multiple stops, and we are very proud about that. Now, the reality is that we are facing a tremendous challenge, and part of that is because of the changes that have taken place in freight trip generation. That is the key. This is a topic that we have been studying for many years. We have been collecting data. In fact, we published two major reports for the National Cooperative Freight and Highway Research Programs, in which we estimated a suite of models to that effect. And these models, the unique aspect of that is that they are basically estimated at the level of establishments that allow us to aggregate results at any level of. Now, we have also been interested in the impacts of e-commerce. In fact, we have been interested in that topic for many years. In fact, in preparation for this lecture, I decided to go back to some of my old papers, and I found this quote from the paper I published in 20 years ago, believe it or not. And 20 years ago, I was concerned about the traffic that e-commerce could bring about. And sadly, that passed, you see. Nowadays, we have this is typical in cities. You have basically a tremendous amount of deliveries, in this case of e-commerce. In fact, the number of deliveries also nowadays is larger, significantly larger than the number of deliveries to commercial establishments. Now, COVID, all of that had been even made worse. What you have here is basically used to be the freight trip generation before. This is basically only business to business. I mean, deliveries to establishments. Now, commerce as a primary form of
Sorry, Professor, your voice is cutting off a bit. It's a bit bumpy.
Maybe it's a connection problem. In essence, e-commerce kind of more than double the number of deliveries to households. Now, with COVID, basically that added another 30 to 40% to the freight traffic in cities. This is the challenge that we have to contend with. Now, with the so-called demand economy, let's say deliveries within the hour or so, these things are going to get worse. Now, what are the key features that, in our opinion, are needed to successfully address climate change in the freight sector? In essence, we need to remember that there are no magic bullets. You see, essentially, we need to address all sources of inefficiencies, because there are many. It's not only the vehicle. We also need to address multiple temporal scales. We need to think about the short term and the longer term. We also need to recognize that there is not a single reality in freight transportation systems and or supply chains. The system is highly heterogeneous. And also, there are multiple unintended effects: congestion, pollution, accidents, aesthetic degradation, etc., etc. In essence, we need to always keep in mind the efficiency paradox. And also, finally, we need to use all weapons. All weapons at our disposal. I mean, it's not only the technology that matters. What this slide shows is basically the energy efficiency framework that we developed as part of a project that we have with the U.S. Department of Energy. Essentially, we tend to think the policymakers is on one aspect of this, that is what we call the base energy consumption of vehicles. You see, that seems to be the primary. But guess what? All the rest, in our opinion, produce the rest of these sources of inefficiency from land use, the structure of the networks, the demand factors, etc., etc. These sectors together are basically more equal or more important than the vehicles themselves. Consider all externalities. Now, there is also this issue of temporal scale. Why is that important? Well, because the reality is that in order to have impacts, we need to implement measures that begin to help now. In the US, there is a tremendous amount of trucks. About nowadays might be 16 million, you see. Now, the vast majority of them are small companies, and small companies that struggle to survive in the markets. And if your companies is the majority of the truckers are struggling to make a living, nobody could expect them to spend money buying the more expensive electric trucks. That will not happen. Implication: we need to do things that basically that we need to implement measures to help these people reduce the amount of energy that they consume and the emissions that they produce. Part of that is that we need to use all possible initiatives. What you have here is kind of like a systematic and comprehensive description of all that could be done to increase the performance of freight transportation systems. And I will invite all of you to try this initiative selector, in which basically you have it's a guide that suggests for the type of problems that you want to look at. It will suggest potential avenues to address that. In essence, we need to use everything: land use policy, traffic management, demand management, pricing, etc., etc., etc. Now, in the long term, we need to think about two distinct areas: metro areas and intercity freight, and also a different time scale: short, medium, and long. In our take, in the short term, pretty much demand management is pretty much the only option that we have. You see, staggering deliveries, off-hour delivery, fostering changes in mode choice, etc., etc. That is pretty much the only option. Same for intercity freight. These are the ones that we need to tackle. And these strategies, as I show you later, have a tremendous impact, basically almost instantaneous. Now, in the short term, there might be basically ways to increase the efficiency of intercity freight. The estimate that I have produced for multiple countries indicate that there is an oversupply of trucks. There are more trucks than they are actually needed in all the countries, the US certainly, Canada, all the countries that have studied. Just by restricting this oversupply, basically freezing trucks, that in the short term is going to increase the level of utilization of the trucks, making them more profitable, reducing freight trips. In essence, and this also has to be considered. In the medium term, then basically we have new technologies that could help: electric trucks, connected trucks. But then we also need to step into what land use could do to increase overall efficiency of freight activity. Again, the situation is similar for intercity freight. Again, in the medium term, in the long term, we could have basically technological means could help. Now, in the longer term, I'm a firm believer that we need to restructure the geographic aspect of the economy. Freight efficient land use, in my opinion, are basically essential. Again, in the longer term, vehicle-related improvements are going to play a bigger role. And then, in the case of this or international freight, kind of very similar, land use, vehicle-related initiative, and also demand management. I want now deeper on choice, on freight mode choice, because it happens that we completed now what might be one of the largest investigations on freight mode choice. This is a very complex problem because mode choice is not a decision by the carrier, it's a decision that is heavily influenced by the shippers or the receiver. And these interactions are typically very complex to account for. As this study, we conducted a great deal of qualitative and quantitative research. In fact, we interview shippers in the United States, the biggest among the big. And what came clear from these interviews is that the key factors in the decision is basically cost and quality of service, reliability, etc., etc. Transit time was a very minor factor. And why do I mention this? Because in most cases where the public sector has tried to intervene to foster beneficial changes in freight mode choice from trucking to rail, in most cases, what they have focused on is reducing transit times. And transit time, according to this and according to econometric models that we estimated, are not. Public sector money will be better spent, basically inducing or helping railroads to increase reliability and quality of service, which is a completely different problem. As part of the quantitative research, we basically used the confidential version of the commodity flow survey to estimate econometric models. Literally thousands of models. Basically, what you have here is like a summary of the key result. It's a mapping of what sectors are the most inclined to be induced to move to rail. And this chart kind of tells you a bit about the challenge, because here, as you can see in the lower right of this over here, these are the commodities that basically they're already being transported by rail. And then here, this cluster number 2 might be like the next step. But from the issue is that moving from the cluster 2 to cluster 3 and 4 will be a tremendous challenge for rail. Implications of that, essentially, we need to emphasize improvements in reliability, quality of service, and that is something that is typically overlooked by policymakers, and that is the issue. Now, in the area of freight demand, there are tremendous potential. I'm going to show you 2 cases in which that we have estimated. The results I'm going to show here are basically produce computational system that we develop with funding from international organizations to use archival GPS data to infer emissions and generalize costs of freight activity. In the case of our deliveries, In essence, what you have here is the trajectory of two trucks, one of them doing deliveries in the night hours and the other doing deliveries in the day hours. And essence, what you can see here was a tremendous terms of the emission produced. In fact, you can see here that this truck traveling in the day hours travel 25 kilometers extra just to make essentially the same deliveries as the truck to the right. And this is basically is an extra distance just to bypass congestion in the tunnels and bridges that connect New Jersey to New York. And this is the effect of congestion. Now, here you have a similar view of all the data. And what you see here is the effect of the river crossings leading to Manhattan. Essentially, as you can see here, the lines in green represent deliveries in the night hours. In the night hours, the trucks travel longer because they're delivering to more receivers. And that translates into tremendous reductions in emissions on a per mile or per kilometer basis. What you have here, we as part of this research, we basically collected data in a number of our delivery implementations and processed them. And at the end, these are the results. Essentially, even small changes in time of delivery, like in the case of Bogota, Colombia, the off-hour delivery trial that is now a project in Bogota, initially only focused on 6 to 10 p.m. Basically, I mean, it's a handful of hours delaying that into the night. And that in itself reduced emission by 13%. Now, in the case of New York City and Sao Paulo, that basically the off-hour deliveries were made deep into the night. So as a comparative measure, the by President Obama before leaving office were calling for 25% in 10 years, 25% increase in the energy efficiency of trucks. 25%. And this simply shifting the time of travel reduces the emissions produced by these trucks by a factor that is larger than this 25% that was the aspiration of President Obama. And on top of that, this is benefit the local economy. It is cheaper if you compute the generalized cost for these cases, it's between 30 to 55% the cost of deliveries, which is astronomical. Now, if we scale that at the level of the planet, we get megatons of improvement. That, by the way, will benefit the most developing countries. That they are the ones that have the largest metropolitan areas. In the case of staggered deliveries, basically we took a look at basically travel to deliveries to the port, in this case containers. We post-process data that we collect, archival data. And basically what we found here is that the staggering deliveries, if we even the timing, the frequency of trucks arriving at the port of New York and New Jersey, basically that will lead reductions in the range of 5 to 31% depending on the origin. Now, why do I say depending on the origin? Because it happens that the origins closer to the port, that is basically where the majority of people live, these origins are associated with the largest emission rates. In essence, the largest savings will take place where they are needed the most. Implications. In essence, we need to use demand management. Basically, that will benefit the industry, will benefit the economy, and also will help fight climate change. Another aspect here is basically the issue of land use. I'm going to show you like an extreme case That is the case of Cali, Colombia. In Cali, Colombia, it's a metropolitan area with three major cities, Jumbo to the north, and Jamundí at the bottom. Essentially, these three cities basically follow different strategies. Jumbo to the north focus on attracting businesses, industrial plants, and distribution centers. And then Jamundí to the south, they decided to provide low-income housing. And now, basically, as a result of that, the manufacturing activities and disease are at the north of the area, and then all the rest of the city is growing to the south. And now you have the low-income workers have to travel all the way from the south. This is a metropolitan area that is constrained by the Andes Mountains here and the floodplains of the Cauca River. In essence, they have either to the north or to the south. And basically now there is a tremendous traffic going from the south all the way to the north to work at these industrial areas. And then all the freight comes from the north and have to traverse the entire metropolitan area. I mean, tremendous congestion. This is not efficient. Now, as part of this research that we have conducted on freight efficient land uses, in essence, what you're recommending is to weave freight activity to the fabric of the economy. Instead of segregation of freight activities, in essence, we are favoring integration with the rest of the economy. Essentially, to do that, we need to explore the synergies between policy and transportation policy. One of the key obstacles to a sensible freight land use policy is the reluctance of local communities to have freight facilities in their midst. Now, this could be resolved by basically enlightened policy making. In essence, if we use transportation policy measures to externalities produced by freight activity, we are going to exploit the synergies of transportation. In the traditional new urbanism paradigm, the idea is to have freight facilities segregated here. And this is not what we need. They have worked, let's say, in 100 years ago, when the Industrial Revolution was basically starting. But nowadays, we are all producers and consumers of supplies. We all of us produce freight trips. In essence, we need to account for that reality. Instead of segregation of freight activity, what we believe is integration, is seamless integration with the rest of them. In essence, we need to weave into the urban fabric basically a small activity centers in order to provide the capillarity that we need. Now, technologies play a role. We are basically in a midst of technological changes and also society changes, including anti-globalization. You see, what we have here have at one level the individual decisions that affect our demand, the demand that we generate. But these decisions at some point basically produce major impacts at the system level. And it's not clear what will be net effect of these trends. We are living in the midst of a tsunami of technologies, truck platooning, truck drone combinations, etc., etc., etc. This of the European platooning challenge could play a role for, let's say, transferring cargo between ports to distribution centers and drones. You see, a lot of interest in that. Drones might be, in my view, a good solution for maybe delivered to the servers, you see. But in general, I do not think that they are a major player overall. We also have all these profusion of technologies in which that are associated with new business models, like grocery delivery services, basically prepared food deliveries, etc. But all of that is adding tremendous pressure to the core side. And somehow we need to have clever core side management. Just to go, is what I want to leave with all of you. Number one is the idea that complex problems do not have magic solutions. You see, problem defies simple solutions. Complex problems require sophisticated solutions. That is the bottom line. The gravity of climate change, we have no time to lose. We cannot, if we accept the validity of this first bullet, we need to employ all the weapons that we have. We need to tackle all inefficiencies, all temporal scales. I mean, we need to tailor solutions for different realities. And we need to see, all weapons must be used. Management, infrastructure management, etc. Accept that this is a complex problem for which, I mean, magic solutions